3 stages to lift the 3 guys into space for about 10 days, with supplies and stuff. And so that thing was designed for that, and that's why it's so large, and that's the last time they ever had an application for it, okay? 3-man crew. We put 2 on the surface of the moon so they could help each other in case somebody got in trouble. And 1 would stay aloft in moon orbit to keep things tidy up there with the spacecraft that would get them back to Earth. So we sent 3 men out in 2 spaceships, I'll show you in a minute, connected together. And we got pretty snazzy towards the end there and threw in a vehicle because they were getting tired. Now the vehicle, they weren't allowed to go any further out than they could walk back. That's how much we trusted the vehicle. But they could do it 3 times in a mission instead of 2. And that kept everybody happy. And the whole thing was controlled from Clear Lake City in Houston, Texas. It was part of a campus of the University of Texas in which Lady Bird had a lot to say. She was the wife of President Johnson, who at the time was the one that started the Apollo program. So obviously, he would put it on her property. She told him to. Right? Cost of average about 6 landings was roughly a little over 20 billion, give or take a dime. And the space race was part of the Cold War. The people that got us all our stuff were the Russians. Like Khrushchev came over here very frequently, bragging that they were ahead, as they were. And we got a big impetus from the public for that. But anyway, we got a program started, and these are comments made by both the Russians and our management in the federal government. It was the highest missile ever built, 363 feet. That's a long way up. And it was 90, we had a game we played, we still do that, in engineering circles of reliability at 99.9 that allowed 6,000 parts to fail every launch. Obviously they didn't because we got there, but that's how numbers are played. It weighed 250,000 pounds, and countdown was a mere 1,700 pages just to get them off the ground. 12 Americans will explore the moon, and I won't show things in dimensional accuracy, just visual, physically. But we are 93 million miles away from the sun, still getting enough sunlight, and we travel at around 67,000 miles an hour, and our satellite travels around the Earth, along with the Earth. And so this is the aerospace arena that we flew in. And of course, there's nothing else out there, thank heavens. There are little rocks. And the average speed of the moon is about 2,200 miles an hour. And it rotates slowly. And we always flew from equator to equator, but the concentration of mass was most level there. And even though McDivitt wanted us to go to Tycho, which is on the south pole of the moon, and we could not do that because it was not an equatorial orbit, okay? All in the hard vacuum of inertial space, 250,000 miles, a little over, almost 3 days out, 3 days back, just sitting there in free fall, with hopefully nothing bumping into the spacecraft. Our universe in this area around the sun is pretty clean. There are no big rocks and boulders going out there. And so 7 missions went out, and 7 came back, and nobody ever hit anything, because there's nothing out there to hit. We had to get the spacecraft thing is for moon orbit work only, to bring the crew home, and the front end is going to land on the moon and stay forever on the moon. So there are 6 of this landing stage parked along the equator, roughly, of the moon because of the Apollo program. Okay, so get into orbit, get a nice burst velocity going, go to 250 miles in roughly 3 days. And there's virtually, we work very hard so that there is nothing to do but sit there and watch and sit together. So I put you 3 in the closet. I'm scared the hell out of you. that was the environment, okay? All in a hard vacuum of space. So you had to rely on your spacecraft. And we did not maintain the pressure inside the spacecraft at 14. It was at 5. Because humans can survive at 5. And that's a lot cheaper and weighs a lot less than 14. So off they went for 3 days. Back they came for 3 days, and in between time they spent their time in the moon. So in order to get enough peripheral velocity out of Earth orbit to get to the moon, you have to do about 24,000 miles an hour at the initiation of this trajectory, and then shut your engine off, and you can leave it off, okay? And then in order to intercept the moon, and you get there, you have to slow yourself down so you can fall into moon orbit, otherwise you'd swing right around. We set it up so you swing right around and be right back to Earth if anything had gone wrong. And nothing ever did. We always went on our way. All in the hard vacuum of inertial space. Let's see if we can get this going. So, the specs are, get yourself into a 100-mile orbit, do it in about 17.5, and then at the right point in that orbit, aimed at the moon, get your velocity up to where you cover 24,000 miles an hour in about 3 days. And then you sit there. If something happens on the way out and around, keep your hands in your lap. The moon is set up so that, the trajectory is set up so that it would swing around under moon gravity and the moon would throw it right back to Earth. If a disaster of some sort occurred, requiring to abort the mission. The command module, which is that thing right there, stayed aloft in moon orbit, watching everything going, and the lander disconnected from the spacecraft and it landed 2 men. One stayed aloft, 2 stayed below on the ground. All right, so that's the lander there, and the 2 are separated right now. And here's the nudge towards landing along the equator because it saves fuel. And so most of our trajectory work was done along the equatorial plane of the moon as it intersects the Earth. And it was called, at the time we were, of course, arguing with the Russians about going there, and we named it US-1. So, they never made it. And so the command module with 1 member aboard would keep everything safely aloft and working, while 2 guys crawl forward into the lander, land, do their thing, and then come back and join the crew, and all 3 come back and command module. Okay, and so the 2 of them are often seen floating around up there together, angling for maneuvers, and like we say, we named it US-1. And the outliers, 15, 16, and 17, brought back the most rocks, because we got a little bolder as each mission went on with success. So we brought more and more weight back per mission. But we never dared go to Tycho. We have our hearts set on going to Tycho. But in order to send us, you got to put us into a controversial orbit of the poles. And so far, nobody has volunteered money for that. Yeah. I thought it was quite selfish of the people, but it so happens that most of our exploration was in the front side where we could see them and be under control, mission control, and monitor everything, and only miscommunicating with them for a half a moon orbit, and everything was done along the carrier because that was cheaper in fuel. The scientists were going nuts. Hey, let's go there, there's a nice rock there, we'll pick that one up. you go or we think we can get back with the story. And so, up above is the command module and the lander hooked together in a way that they are when they travel between Earth and the moon. And then the lander lands, and we got bold enough towards the end. We sent a car along with them. Now, the car was certainly capable of taking them farther away than they had been going on foot. But they weren't allowed to go any further on foot than they could get back on foot. So we just went out 3 times instead of 2 with the lunar rover there, because no one could leave the vicinity more than they could walk back in one session. And we had planned from 7 until about 20, and at all kinds of fancy places, plotted out for along the moon, and it turned out that 13 blew up on the pad, as you may have caught fire on the pad. And first time in the history of Air Force, NASA, Navy, anything, that anything caught, any aircraft caught fire on the launch pad. It was humiliating beyond recall, and a disaster, of course. And then we ran out of money. So that was your fault. So I can only bore you to 17. We could have gone to 20. On the other hand, it was a great trip, and we got a lot of good stuff out of it. So nobody really minded. 7 was, okay, the yellow ones were the ones where we went to the moon. The others were Earth orbit, fooling around, trying to make everything work in near Earth orbits. And so we didn't get started until Apollo 11 first landed in the Sea of Tranquility, and then 12, 13 blew up on the way out. We were lucky. I'm still praying for that. Got them all back alive, and then 14, 15, 16, 17, then we ran out of money. And I don't blame you, to tell you the truth. So this is how it went, and the vehicle only took them out 3 times instead of only allowing them to go out 2 if they walked. So we could go off in 3 different directions from the landing site because we had the rover with us, and they could ride, and they could get out there and back farther. And that's where the rover came into use. But we never went any further than they could walk back. And this is the names of the places we went: Sea of Tranquility, Ocean Storm, Tomorrow, Esri Apennine, Descartes, and Tars Littoral. And every time we went out, we got more stuff, because we got bolder about packing it into the command module as it would lift off the moon. Remember, we got to lift all this stuff off the moon, put it in the moon orbit, and get back to Earth. And so as we got bolder, we got more rocks. And so all of these rocks allegedly went out in the world, and I don't know what happened to them. They never reported, gee, I found something special. But it was none of my business anyway, so it's been distributed around the educational community, a lot of this stuff for analysis, and you can probably probe it if you want. So we brought back a total of 840 pounds in a total of 10 days of actually walking around on the moon for all the mission time and expense. Comparable size, not distance, moon and Earth. Our moon has a small molten iron core, yes indeed. Lumpy gravity model. It's not nice and smooth like the Earth's. So when we're going around the equator, hopefully maintaining altitude, we are not. We're going in and out, up and down a tad, because it is not that much volcanic inside. It's got a drip and drab in there, but not enough. It's just a bunch of solid rocks. When it's going to come apart and come down, I don't know. I don't think ever. No atmosphere, no collectible water, They speak of going to Mars, and logistically it makes sense to go to the moon, go from the moon to Mars because that's a cheaper, lighter equipment. You don't have to mess with Earth gravity and the air mass. And so, if it ever happens, you probably will initiate a Mars mission from the moon after first establishing a facility on the moon's surface. But it has no collectible water. There is moisture, allegedly, in the shadows of Tycho and some of those objects toward the South Pole, but not in water form. Whenever I talk to them, I always get confused, so I just walk away and say, okay, there's some kind of watery stuff there, but it's not for drinking or anything else. No plate tectonics. It's an ancient lava crust, mostly obliterated by impacts. We in the moon went through quite an impact series, about 4.5 billion years old. Apollo was non-military, listen up, this is America, non-commercial, non-scientific, space engineering part of the Cold War. So, all you engineers stand up and take a cheer, all the money was spent on engineering, and that settles that, and that's why we're not doing anything anymore. So there they are, all dressed up and settled down. Both sides had used military pilots to start with because they were disciplined and they had the nerve. And it wasn't until the last mission or so that we actually buttoned up a geologist and sent him to the moon. And it was a funny thing. When they landed, the geologist says, who was in command by me, says, we're not leaving the spacecraft till we stand up and look out the top and survey and decide based on what we see where to go, not just to jump out and run, which is a geologist for you every time. So, let's see. Okay. So, we actually did try to, well, I say we did. We did try to do things with the Russians. At the same time, the Russians were launching bigger and bigger boosters. They never got to launch one successfully. There's the Saturn V. We never managed to build a Saturn V size missile that worked. And so they literally destroyed their pads and a lot of people in tremendous fires. I think I got a picture of one here. But during the geophysical year 57-58, the Russians were out to show the world that they were better than we. So they were the first to launch a satellite called Bell Traveler. All it did is beep, 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 but it sure attracted a lot of attention from everybody. So the Russians win the race, and this is the satellite that they put up, a Sputnik. And it simply was there first. Weighed 184 pounds, which was tremendous from our point of view, because we couldn't launch anything. And they also deliberately broadcast an ID signal using radio ham, because they knew all you hams would be picking this stuff up. Hey, Mom, right from Russia, you know. So that's the kind of happened. So 4 months later, we got the Navy to put up a small missile, weighed 31 pounds, called Explorer 1, and we claimed we were in grace, which we were, but we were losing. So that weighed 31 pounds, whereas the Russians weighed 184, so which had much bigger booster capital. And Khrushchev was a man of no humility. So he made sure at every bar there was a conversation about the Russians. Put the big one up there. And he really rubbed it in Kennedy's face. And Kennedy was, of course, kind of an elitist intellectual who was insulted by the fact that this guy was keep calling him lightweight. So he decided, well, we're not going to mess around. And this was all due to orbital shenanigans. Russians put up satellites, nobody's going to the moon yet. So we were still horsing around in Earth space. And the Russians they sent up were just missiles that would lob up and come down again. So Lyndon, Kennedy says, Lyndon was his vice president, Lyndon Johnson, he didn't care what we did. What can we do to beat the Russians? And it certainly was nothing to do in Earth orbit because they had us. They were there with bigger ones, faster ones, and more. So Lyndon decided that we're going to go to the moon. And everybody jumped up and said, are you crazy? And to a politician, that's not crazy. But at the time it was. We had nothing in the basket to go to the moon. And eventually we finally made a lander that would do nothing but land on the moon. That was cool. Oh, the limb. So we lost 3 astronauts in a spacecraft fire on the pad. First time ever happened in aviation history that during a test on the pad we lost a crew. We usually lost crews in space, in the airspace, or in space. And that gave us a big start. And this is, you had a train with a lunar landing craft that weighed what the LEM did. That means we had rockets biasing its weight out to a third of what it was. And you flew around in that contraption. And that's Neil Armstrong sitting up front there, practicing flying. That thing flies. Okay? And not quite. And he got down 4 feet after this thing hit the ground. He was in the smoke there. You see his chute headed down towards the smoke. He gets up, Neil doesn't, goes to his office and sits down, starts the paperwork. And everybody thought he was a bit weird because we did take mostly Air Force pilots and Navy pilots, and they would go in crews of 3 who usually knew each other in the service. With the exception of Neil, who was a civilian by the time he got into the aerospace business, and so Neil could pick anybody you want, and that's how you got Buzz Aldrin and crewmate. So, what did we do here? First, we did with what we had. We did what we were limited to by the boosters. And we only had small boosters, so we could only throw 1 man up. So we threw Mercury up and declared ourselves in the race, the Russians. And then we threw up Gemini because we had a booster big enough for 2 men. And then finally we would get to 3-man spacecraft and a booster large enough to put that whole thing up as our final design for Apollo, which took us from 11 to 17. 3 men would go out and travel out and back in that thing. This is empty, the lander's empty, just sitting there doing nothing. And we get to the moon orbit, 2 go forward, climb in, activate, unbuckle, land, fly back. This is a lot to do. Rendezvous and make up, and then there's I think there's 4 or 5 of these things buried in the moon somewhere. So if you're up there, let us know. It's history of the Apollo program. 13 was border on the way up, which was a disaster. But we saved the crew. We were in these missions that, on the way out to the moon, we were in an orbit to the moon that would take us around the moon, not down to the moon, and back to Earth automatic with your hands in your lap, allegedly. So that was the safety procedure getting there. If something busted, you had to go all the way out, around and back, and the moon would sling you back to Earth. And that worked out pretty well. Let's see. Okay, I'll just explain that. So this was the configuration. You see these spacecrafts on the television. They don't look like this at all. The bottom half is the lander. The lander will be broken into 2 parts. The bottom part, which is gold, I don't know why they put gold on it, but it's gold. And the bottom part would stay at the landing site because it landed us, and then the top part of the lander would lift off, rejoin the top part, the command module, hook up, and then throw the top of the lander. Now that's very confusing, but just remember, anything that wasn't going to do some work was dumped in space, okay? So we got a lot of stuff all over the surface of the moon, and a lot of stuff in Earth, moon orbit, which you'll never climb with, because it's so big and empty out there. So the lunar lander was a descent stage. The lander engine was adjustable thrust and pitch and yaw. That was a big deal in those days, getting rocket engines that would change and pitch and yaw without blowing themselves up, and throttle them. They could throttle them up or throttle them down. That was really a breakthrough in engine design, and that was called the lander stage. The lander stage was the takeoff station for the ascent of the top half back to the moon orbit, and then they would rendezvous with the command module, which is left in moon orbit for just that purpose. Get the crew to rendezvous, get together, get all three together, and come on home. Okay. So the lunar lander cockpit, standing room only, no seats. I'll show you that in a minute. And the command module was a three-man crew, could sit or stand once they got back in. That's the nose cone. And the back thing there was all the material they needed for 6 days to 8 days of floating around out there with nothing else around but empty space. Okay. And it had one engine on that stage for major thrusts between Earth and Moon to get out there and get back for that kind of work. And all that was left when we got back to Earth was the nose cone of that whole configuration with 3 guys in it, hoping that the heat shield held out. Okay? Which it did. And that was the heat. So we dumped all of the Russians, that sounds catty, but the Russians were very cautious about landing on land because they didn't want us to see anything. No spies. And so they dumped all their stuff in the backwoods of Soviet space, and they're generally found by some farmer out there raking hay, and this thing lands. We landed in the ocean where we could get the entire Navy in there to help with the rescue and ensure their safety. And the whole world, of course, could see it because the oceans are free to cruise. And that was how they kind of got defeated by the way they think about things. And I just thought we were better. So Levin landed in the ocean. Here's the difference between the Russians and us. I mean, you never send anything in space more than you need, so you don't have to worry about how it looks, or how it deflects air, or how it heats up. You just put it together and send it. And so the configurations we sent out and they sent out look kind of junky, but they're all very functional, or just the function they were for. And the minute it got used, it was thrown away. And I think I'll show you that. So Earth to Moon transportation was that big ugly thing. And Moon lander was that. And let's see what we did. Okay, the 2-man crew, this they inherited from their orbital work. They never changed their basic spacecraft for exploring space. They just made it emptier. And so the crew sat there, and there was only 2 of them, whereas we took 3. Otherwise, everybody threw everything away as quickly as they got done using it. And all that came back to Earth was that 2-man crew thing on the back for the Russians and our lander. So the Soviets never made it to the surface of the moon with any kind of a lander. They plunked down plenty of things, little bitty things that would roll along, grab some dust, and take off. And I think 1 or 2 made it back, but that was it. One stage when they went up, yeah. So